Hello and welcome to Data Protection with Tanzu Mission Control. So before we dive into the topic, let's step back a moment and ask ourselves, do we really need backup and restore for containerized workloads? You hear some skeptical voices and some people really asking and stating that an application has to handle backup and restore by itself. And others claim that the cloud-native workloads running on Kubernetes clusters are stateless. And sometimes we think that all deployments on Kubernetes are versioned and stored in Git. So there will be no reason for a backup and no need for a restore. But is this the reality? Are we really sure that every application handles its own backup and restore? Are all workloads on Kubernetes stateless? And do we really know that everyone who deploys a workload on his Kubernetes cluster does also version it and is able to reproduce it easily? Or is it just the desired state we aspire to reach? So the facts that I see with customers is that they start containerizing an application and then incrementally improve it. So maybe at first it doesn't start up with a perfect backup and restore, but it's something that we want to implement later on. Now what's really important here is that not every application starts reinventing the wheel, and in the end you as a platform administrator end up with 1,000 snowflakes. Guess whom they will turn up to if they are facing troubles with their backup, troubles with their restore. So you want to have a standardized way of doing backup and restore. Now, data protection in TMC with Velero can be your safety net until the application owner feels comfortable with their backup and restore. We also see that microservices, they are also driving not just microservice application architecture, but a microservice data architecture, mandating that each microservice has also its own data. No longer one large database who is run somewhere, but everyone has its own smaller databases, persistence layers that ideally they would like to run side by side on the applications. We want to run them on Kubernetes as well. So we see many deployments of persistent workloads. It started out in dev and test, but it's very easy to predict that we will see them in production very soon, if you don't already have them. So with this, now let's move to the main topic. So Tanzu Mission Control is a SaaS solution. And as such, it covers many aspects of managing multiple clusters for multiple teams over multiple clouds. As you see on the left-hand side, it takes care of provisioning the clusters and managing the full life cycle on vSphere, on AWS, and soon on Azure. What it already does, it is able to attach every conforming Kubernetes cluster, as you see on the right-hand side. So also Rancher, OpenShift, clusters from all the major cloud providers. Every conforming cluster can be attached and managed. We're speaking mostly of identity and access management, security compliance, and audit, a policy-driven management. Now, the topic of this speech especially is to look at the data protection part, which is based on Velero. Data protection as a feature within Mission Control allows you to centrally manage backup and restore of the entire cluster fleet. And it is built on Velero. What TMC offers on top of Velero is that it installs and manages the lifecycle of Velero in your clusters, no matter where they're located. So initial installation as well as updates and upgrades of the Velero software. And you can then use the TMC GUI, the CLI or the API to backup and restore. And TMC, through its agents, will pass these commands to Velero, who will then execute them on your cluster. To store the backups, Velero uses S3 compatible storage, where it will store the backup information, and to backup the data, it will use snapshots, as we will see. So what will we see today in the demo? Now here is an overview of what we will go through and the different locations that we will use during the demo. So first of all, we have our laptop, my laptop, where I will be driving the whole demo. Then we have here the ability by CLI or user interface to work with Tanzu Mission Control. Remember, this gives us the multi-cluster, multi-team and multi-cloud ability. And one of the things that we will see is the deployment of the cluster. So Tanzu Mission Control, I will first deploy this cluster here, the TKG Kubernetes cluster that you see on the right half bottom. And once we have deployed that cluster, the next thing we want to do is then we want to set up Velero. So we will enable data protection on that cluster. So Tanzu Mission Control will automatically deploy Velero to your cluster, and we will then have the Velero namespace, and we will from then on be able, either through the CMC, CLI and UI, to do data protection, backups and restores, or from the Velero CLI directly from the laptop talking to Velero on the cluster to also list what we did from TMC, basically also doing backups, doing restores and seeing the logs and all that stuff. So once we have this in place, we need something to back up and test if the restore works properly. So what we will do is we will deploy this Up Close blog based on WordPress, which has a WordPress part, a database part, and both will have persistent volumes to store their data that we change. So we'll do some changes to that blog. To deploy that WordPress instance, MariaDB, we will use Bitnami, which is the community project behind the Tanzu application catalog and has curated images and Helm charts. So we will deploy a Helm chart from the Tanzu application catalog to run in our Up Close namespace and run our WordPress blog. Now that we have set up this with the changes, we will make a backup. So we will trigger a backup with Velero, and this will do two things. First, it will create snapshots of the persistent volumes that are powering our WordPress MariaDB, and it will also write all the metadata about that backup into an S3 bucket or S3 compatible storage. Now in this case, we will have all this on AWS, but any S3 compatible storage will do, and currently we're supporting AWS and vSphere as locations where your cluster is running. So what do we see in TMC? In Tanzu Mission Control, this is greeting you, this is the default view. You see we have a couple of clusters already here, as mentioned, different footprints on different infrastructure providers. And what you can do to group your clusters is you can work with cluster groups. Now I created my own cluster group and I created the filter so I only see my cluster group. If I look at this, at the moment it is completely empty, so we don't have a cluster at the moment. As I mentioned, we want to create one. We will create one on AWS. So let's have a look at AWS. We have 0 instances running at the moment. We have 0 volumes, 0 snapshots. And if we go to S3, as I mentioned, that we will store the metadata there, we see that we have multiple buckets. The one that we're interested in today is the VMware TMC DP bucket. And as you see, this is all empty right now. We will fill it up later. So Let's move to the command line as, well, we need a cluster to get started. I can do it on the GUI, and we'll show you later how to do that, but just to do it quickly and repeatably, we'll do it on the command line. So we do tmc cluster create. We have the name of the cluster that we will pass and the cluster group. And then we specify where we want to have that cluster. And the last one is which public key I want to use to access it. Then we specify where to run it, the availability zones, and we specify how many worker nodes. And by default, I will install a dev type cluster with just one master node, one control node. There's also the ability to multiply redundant control nodes. So with the default template, we'll have just one control plane node, and the cluster is being created in the background for us. So we will revisit that later on and get working with our cluster. But while the cluster is creating, we will have a look at what we want to do then. Once we will have created the cluster, we will start to deploy an application on that. And to do that, we will get some help from Bitnami. So what could be a stateful application that we want to deploy and run as an example? Let's see. We have the Tanzu application catalog, which is the enterprise offering, and we have Bitnami, which is the community version of it. So let's go to the community version. And let's pick the WordPress example. So why did I take the WordPress example? Well, it has a front end that we can configure. It has a backend, the database. So it already is that pattern that I've been talking before. And why am I using Bitnami? Well, Bitnami is a really nice way. You add the Helm repository so that you can access the charts, and then you can easily deploy WordPress. But it's not just the ease of deployment, it's also that these images are always fresh. So they're constantly updated to fix vulnerabilities, they take care of new releases and so on. And let's quickly check what they are also doing in terms of security. So if we're looking for one piece as running a container as a non-privileged user. So what Bitnami does for us, it sets the container security context to user 1001 and also sets run as non-root to true. So the container that we will deploy will execute as a non-root user, non-privileged user, which is good practice. So this is the reasoning behind using Bitnami for that deployment, so that we know that we are safe from the patches side and also from the configuration side. Now let's head back to Tanzu Mission Control and let's see if something is happening already. Now we see that in my cluster group that we specified, we start seeing cluster, and it is on step 1 of 4 of creating infrastructure. So this will take a while, so let's check back later when it is completed. While the cluster is still creating, let's have a look at what it would look like to create a cluster on the GUI. We did it from the command line, so we're here in the cluster view, and let's hit create cluster. So first, we specify which management cluster we want to use. We will use the AWS hosted, as in the example on the command line. And then we will select provisioner. Remember, provisioner was my username with the -AWS. and also the same account credentials. Now as cluster name, let's use a Schmidt test, and the cluster group, as mentioned, I have my own cluster group, so I can see all the clusters in one place conveniently. We could add description, optional labels, but we're good for now, so let's click Next. We can configure the region where we want to run that. So we will run it in EU Central. We specify the SSH key, and here we can specify the version. It might be that we want to start with a version that we already have tested, that we want to run in production right now, but we can also leave it at the newest. The advantage of specifying an older one is that we can then see that we can upgrade that cluster also from within TMC. We can specify if we want to have from the networking side some new things. If we want to modify the IP addresses, we will leave them at the defaults. Here, as I mentioned, you can have a single node control or a highly available control playing with 3 nodes, 3 master nodes configured. And as you see, then you specify which availability zones they will be in. And then you have a node pool, you have the worker instance type that you can select from, and you have the number of worker nodes that you can specify. So this is all you have to do. You hit create cluster, and behind the scenes it will deploy the same as we have seen with using the CLI. So I'll move away from this one as we don't need a second cluster for our demo. So we're good with this one. Let's see where it is. And it deployed in the meantime. So let's see. It says healthy up here. All the agents and extensions have been installed. We here have an overview of the nodes. We see the namespaces currently running on the system. And we could schedule an inspection to see if everything is conforming to best practices. We can also run a CIS benchmark to prove that our cluster is secure. Back to the overview. On the overview here we have integrations, so we can already configure a service mesh if we want, or attach observability. That's not part of today's demo, so what we want to do today is we want to go to the data protection, and we see that data protection is not enabled for our cluster, so we'll need to do that. Before we can do this, we will have to do some work that I already did before. So under administration, you can create account credentials for AWS data protection. This will create the credentials so that data protection can create the snapshots and store the backups, the metadata in S3. As I said, I already did that, so you will see here my account. It is already set up for data protection. So back to our cluster, and let's enable data protection. That's all we had to do. So provide the credentials and enable. With this, it will take a moment to install Velero onto the cluster to enable us to do the backups and do the restores. So while this is running, we already have the cluster, but we don't have a workload at the moment. So let's take care of that. To do this, we need to be able to access our cluster. So let's go back to the command line and get access to our cluster. We can do that simply with the command line with TMC. So we're asking for the cluster authentication, for the kubeconfig, for our cluster, and Schmidt data prot, and we will store that in a file. So we have the file, we have the kubeconfig. Now let's set the kubeconfig environment variable to be able to access it. Let's do a quick check. Yeah, yes, seems valid, right? And also the namespaces, they match what we had expected. And we see the Valero namespace, the newest one that started creating for our data protection. So what else can we do? We have one master and two worker nodes as we specified on the command line. Now, we said that we want to run WordPress from Bitnami. So to do so, we will create a separate namespace so that we don't mess with other namespaces and don't use the default namespace. We'll call it Up Close block, and we will do a Helm install, and we will take advantage of the ability to set a couple of variables. So we want to set the block name to Tanzu Up Close, and we're setting username, password, of course, the namespace, and we want to deploy the chart name Bitnami WordPress. So we get a nice warning that we have an insecure kubeconfig file, but other than that, it starts doing the deployment of Up Close in the namespace we specified. So it is deploying at the moment, and we get information of how we can get the service IP so that we can access the blog, open it, obtaining the URL, and so on with the username and the password. We can also just use kubectl to have a look at what's happening in our namespace that we created. And as you see, we have here a pod that is running for MariaDB. We have the WordPress that is creating. We have the load balancer, which has an external IP address, or rather a DNS entry. And we see the deployment for WordPress, and we see the stateful set for the database. So after a while, we see that MariaDB is running, WordPress is starting to run, it's not yet ready. You see the 0 here in front. So in a moment, this will be available and should start answering here on this IP address. And remember that for the admin, we will just add an admin, trading admin on the website. So let's move to the browser and open it up. So this worked nice. So we're here, we're on our WordPress blog, and what we want to do is we want to customize it. Well, maybe let's have a look at the default theme that we have. That's the green default theme of this version that greets us. Oh, I don't like it, so I want to change that right away. So let's go to Appearance and Themes, and let's search for one. I'm especially fond of this one, so I really like it. So let's install that. and activate it. But you know what? For today, we want to do something special. We don't want to go with the default theme. We want to do something more personal, right? So let's add a new image. And let's go with this one. We'll upload it, do some cropping here. And that's really up close, and in a way it's personal, so let's publish this one. And maybe let's have a look here, double check it. Yeah, our changes worked. So we have a custom background, we have Tanzu Up Close that we specified on the command line as the title of this blog. So we have some data that is now running on our Kubernetes cluster. So what's the next step? Well, the next step is go back to Tanzu Machine Control and let's have a look at data protection. So data protection here doesn't circle anymore. We also see here that everything is green. So all extensions have been successfully installed and we're now ready to create a backup. When we create a backup, we have different options here. So one option is to backup the entire cluster. What we also can do is we can backup selected namespaces, or we can backup just resources using a label selector. Most, if not all, of the objects within the Kubernetes clusters are labeled, and so we can really be very specific and create labels of things that we want to backup. For today, we'll go the route of selecting a namespace because we have handily our Up Close block namespace that we can select. So everything within this namespace will be backed up. Now we go to when to backup this data. We can backup now, which is kind of a one-shot backup, or we can specify an hourly backup. So specify at which minute of the hour we want to, a daily backup, which is probably very good if you want to just have a safety net every day that changes are saved. A weekly schedule, maybe to complement an already existing backup. A monthly schedule, and here you can go completely custom with the cron expression. So specifying minute, hour, month, day of week, and so on. The regular and normal cron syntax. We want to do a one-shot backup, we want to backup right now. The next is the backup retention, especially if you're doing these scheduled backups. You don't want to keep them forever. So you want to set a retention that's long enough so that you can go back to one of the backups that you have been doing routinely. We'll stay at 30 days, and what we want to do is we want to name it Up Close Backup 1 and go create. So then we see that on the data protection tab, we see that we have backups, Up Close Backup 1. In case we would have specified a schedule, we would see the schedule here. And in case we already would have done a restore, we would see the restores away. So Up Close Backup completed a few seconds ago, so it's already done. And we see that in the backup, in the details, we see that we back up the namespace Up Close block, that from the backup type we have a partial backup, no label selectors, one namespace, and 2 snapshot volumes. So let's verify this. So what do we see now in AWS? So let's reload. We see that in our bucket where we have our backups, we have a folder with backups, the Up Close Backup 1, and the different artifacts. Looks good here. Let's maybe quickly also check for EC2. So we have instances running, we have volumes, and we have snapshots. Let's have a look at the snapshots. So we have two available snapshots here that were created from the backup. So we've now seen what it looks like within TMC, but it's not the only way we can double check our backups. We also have the ability to look at our backups from the CLI. So to do that, let's go to the command line. Now with Valero get backup, I will simply see that we have the Up Close backup completed. The other thing I can do, I can say Valero describe backup, Up Close backup 1, where I will see what has been included, where I will also see the start and complete the time, basically the information that we also have on the GUI. So we verified, we can see the backup also on the CLI, all good here. So what would then be the next thing? Now we said that something has to happen that we can test our restore, right? So let's see what we have again on our cluster. We have the deployment, we have the stateful set, and there is more. We have persistent volumes and we have persistent volume claims. So we see the persistent volumes, two of them, one for WordPress and one as data for the MariaDB, the database behind it. And we see that we have the claims, and we were interested in this claim especially. So in order to be able to delete the volume and the claim, I first need to make sure that Kubernetes allows me to free these resources. So for that, let's start with the stateful set. Let's delete this one. So now the stateful set is deleted. Now I can move on and say I want to delete this persistent volume claim. So now the persistent volume claim has been deleted. Now if we double check, we see that also the persistent volume is gone. So we no longer have now these objects. Let's see what this did to our blog. So if we try to reach it, we see it spinning up here. So maybe I expect that we should time out. We see it's still waiting down here, not getting a response. Will take a little while to time out, and yeah, here we have the empty response. So it's not working anymore. Now that's the good time to do what everyone should do with a backup. It's time to see if we can restore. So let's head back to Tanzu Mission Control and remember the Data Protection tab. Now here we have no restores at the moment, but we have the backups. So if we now select our backup here or click on it, here we see that we can restore the backup. So to restore the backup, we can just restore the entire backup. We can restore selected namespaces. We only have one. Or we can restore using label selectors. So let's restore the selected namespace, Up Close block. And we have to specify a name. So this will be our Up Close restore 1. And let's restore. We see that it is pending, and it shouldn't take too long. As I said, we're relying on snapshots, so very fast to restore even large sets of data. It claims that it is completed now, so let's go back and let's see on the command line what it looks like. So I'm checking the persistent volume claims. So we see that our MariaDB persistent volume claim reappeared. We also see that we still have a snapshot available here. That's the one for the WordPress. Now, I'm not deleting it again. Let's have a look at all the objects in our namespace. And we see that it's not ready yet, but we are spinning up the containers again. So also the stateful set is here. Now we did the restore from the GUI, but this is not the only way to do a restore. Remember, we had a look with the CLI to see the backup. Now we can also do the same from the CLI with layer restore. With layer restore get, we're just displaying all the restores that have been done, and with describe, I can have a look at our restore. And let's start from the beginning. So we see Up Close restore 1. We see that it is completed. And we see some messages that it could not restore Up Close WordPress because it already exists. So it doesn't restore things that are already present on the system, but it does restore the missing parts, so the missing PV for MariaDB. And it does not redeploy things that are already here. So that's nice. So let's check again what our pods do. And the pods are running again. So I guess we can go back to our browser and go back to this web page, hit refresh, and we're back in business. So restore worked as expected. and we now have our data back. Remember, we were able to just restore the pieces that were missing, that somehow went missing. And so we are able to recover from a catastrophic failure. Now, with this, we clearly see that we can offer to teams who are running their clusters also the ability to do a self-service, to be self-sufficient doing their backups and restores. So no longer having to open up a ticket if something bad happened, simply going to TMC or using the Galera CLI to create a backup or restore a backup. And as you saw, TMC is then the central place to provide this backup service to a cluster, to a fleet of clusters across clouds and teams. And while we should aspire to have each application take care of its own backup, having a standard plan B with TMC data protection is worth the effort. So with this, I'm finished with the demo, and we can open up for questions.